All right, in this next example, we run into a bit of an issue. First of all, like example 1, we're not in factored form. Also, we made a note to ourselves that we must always be set equal to 0. And notice how in example 2, we are not set equal to 0. So that right there is going to be step 1. If we're going to solve by factoring, we need to first make sure we're in standard form, that we are set equal to 0. So how are we going to do that? We just have to do a little bit of rearranging. And for us, what that's going to look like is we just need to simply move that negative 20 over to the other side of the equation. And we can move it by doing the opposite. So we're going to add 20 to the other side. And when we do that, the x squared and 9x don't change at all. But we're just going to add that 20 onto the end. And when we did that, these canceled and left us with equals 0 on the end. And you know what? That is actually exactly what we want. We want to be set equal to 0 in standard form. Once we're here, now we are ready to factor. So here's our factored form, still set equal to 0. And we have to look for two numbers that multiply to C and add, we'll do a plus sign, add to B. This was back to topic 7. In our last example, it was already factored for us, but this time we have to do it ourselves. So what are two numbers that multiply to 20 and add to 9? I'm just going to really quick list off some factors off to the side of 20. So 1 and 20, 2 and 10, 4 and 5, and I think that is it. Which of those combos adds to 9 also? Here's our winner, 4 and 5. All right, let's go ahead and plug those in. It does not matter which factor goes where, but we do know that x always starts out our factors, and those are positive 4, positive 5, so we put plus signs there. All right, now step 3 just says rewrite the standard form of the equation in factored form. We actually already did that. That is step 3. We have it set equal to 0. We are ready to use our zero product property in step 4. So we're going to take our two factors, x plus 5 and x plus 4. We're going to set them equal to 0 and solve them each for their solutions. Now, one pattern you guys are going to start to see is that if these are one-step equations, it's really just the opposite of the factors that we see. So what I mean by that is that my first solution ended up being negative 5, and my second solution ended up being negative 4. Those are our two solutions, negative 5 and negative 4. All right, if you want to try the next two examples on your own, go ahead and pause now. You can check back once you are finished. Otherwise, if you're feeling stuck, go ahead and follow along with me. All right, using the same steps as above, our first step is to make sure we're set equal to 0. And looks like that we already are this time, so we can jump right into step 2. We're ready to factor as soon as we're set equal to 0. So here's our factored form. We're looking for two numbers that multiply to C and add to B. So two numbers that multiply to 64 and add to 16 are 8 and 8, and they are both positive. They multiply to 64 and add to 16. Since these are the same exact factors, we actually only have to do this one time. Set that factor equal to 0, and now we can solve for our solution. And we should be getting x equals negative 8. Just one x-intercept that time, one real solution. Think back to lesson 9.1 and kind of what that parabola looks like then. All right, last example over here. We want to first make sure we're set equal to 0, and this time we are not. So first step, we have to get it to be that way. So we're going to get rid of that 64 by subtracting it. Since it's a positive 64, we want to minus it. Just move it over to the other side so that now we're left with 0 on the right. That's exactly what we want. All right, and when we move that 64 over to the left-hand side, here's what we're left with. And now we are ready to factor. This one's going to be a little bit trickier since we have negatives. We're looking for two numbers that multiply to negative 64 and add to negative 12. So my mind first went to 8. So One of our factors is going to have to be negative and one's going to have to be positive if we want to multiply to a negative 64. So 8 and 8, looks like those are not going to work. So let's see, what other numbers could we do? I'm going to take out my calculator. Try to do 64 divided by some different numbers. So looks like 4 goes into 64, 4 and 16. When I multiply those, we get 64. Let's try to make 4 negative, see what that gets us. So negative 4 times 16 definitely gives us negative 64, but when I add those together, we're going to get a positive 12, and that's not what we need. We need a negative 12. So that tells me the negative must be with the 16. Now if I add those together, we do get our negative 12 and negative 64. All right, let's plug those in. Again, does not matter which one goes where, as long as the 4 is a plus and the 16 is a minus. And then we can go ahead, set our two factors equal to 0, and use our zero product property to solve. All right, we have two solutions, two zeros, x equals negative 4, x equals 16.